Most likely, if you've run into problems, it's in MPLab. So I'll work down the list and then we'll go to hardware issues. Also, most likely, if there's a problem somewhere in MPLab, it should show up as an error in the output box, either when you either build or attempt to program your PIC. For instance, if you attempt to build and you got an error that says something like this, warning 205, yada, 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 found directive in column 1, bank cell. That just means there are no spaces before one of your commands. In such cases, it will give you the line number, which is right here, line 9. And it'll probably even tell you what the directive or command was. All that means is you have to put in at least one space before the command. This is column 1, and the first column is reserved for what we call labels. I'll explain what labels are in the next lesson. So in your whole program, there should really only be one line that is all the way to the left in column 1, and that is this label. If you get a whole mess of errors with ones like this, executable code and data must be defined in an appropriate section, yada, 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 or labels must be defined in a code or data section when making an object file, then most likely what happened is the absolute mode checkbox didn't get checked. So right click on the project name, select properties, click on MP Assembler Global Options, and check build in absolute mode. Then click apply and OK. If you got some nasty pop-up window warnings like this, and or this, and then finally the message, failed to program device. This is because low voltage programming mode didn't get selected in MPLab. Older PICs could be put into programming mode by applying a higher voltage like 8 or 9 volts on a specific pin. The newer PICs, including the 1455, support low voltage programming where we only need to hold a couple of pins low and put a high on the MCLR pin. But we need to tell MPLab to use low voltage mode. Apparently yours didn't get selected if you're getting that error. So again, right click on the project name and select properties. Click on the Picket 3. Set the option categories button, or drop-down box, to program options, and check the enable low voltage programming checkbox. Click on apply and then OK. If you get this pop-up window, target device ID is invalid device, please check your connections. Double check and make sure that the wiring from your Picket 3 to your PIC is correct. You might get a failure to program and a weird error, something like this. Picket 3 is trying to supply 5 volts from the USB port, but the target VDD is measured to be 4.75 volts. This could be due to the USB port power capabilities or the target circuitry affecting the measured VDD. Basically, this is a limitation of the USB port on your computer. The USB port can't supply the voltage you are asking it to. In my error, you can see it even told me what voltage it was actually getting out of the Picket, only 4.75 volts. You can turn down the demand by again right-clicking on the project file and selecting properties. Click on Picket 3 and change the option categories drop-down menu to power. In my error, it told me what voltage it was actually getting out of the Picket, 4.75 volts. So just turn the voltage level down to whatever it said in the error or something slightly lower. We had originally set it up as 4.5 volts, and that worked on my desktop computer. I think I had to set it even lower on my laptop to something like 3.75 volts. Click apply, then OK. Lastly, if you attempt to program and you get an error window like this, it means either your picket isn't plugged in, or it got unplugged, or it didn't install correctly. Just remember, for whatever reason, the picket drivers on Windows machines took forever to install. Wait until you get the message, drivers installed successfully, device is ready for use. If it just absolutely refuses to install, you can try just simply unplugging it, counting to 30, and then replugging it back in, see what it does. You can also close down MP Lab and restart it again after you've plugged in your picket. You may ultimately have to manually install the drivers in Windows, but I haven't run into that problem yet on multiple PCs. All right, moving along to hardware. If the PIC was showing as programmed successfully, but it's not flashing its LED, or the LED is staying on permanently, there's some things we can check. First, is the LED from your 555 flashing? If not, that's the clock driving the PIC. The PIC will do nothing without a clock. I'll leave it to you to troubleshoot your 555 circuit. Then double check all of your wiring on the PIC. Now remember, pin 1 is the positive supply, pin 14 is negative. It's like the chip is built upside down. Make sure you've got the power connected correctly. Secondly, is the clock pulse going to pin from the 555 to pin 2? That's the clock input pin. Do you have the resistor and LED coming off of pin 7? That's the pin we programmed for the output. Did you change your code in your program back to FF? If you're still having issues, copy the errors and paste them into a post in the comments section and ask what's going on. We'll see if we can figure it out.